Okay, here we go, on to something new, definitely cool. Okay, complicated? Well, yeah, unfortunately, this always happens, right? All right, is it worth it? And the answer is yeah, it definitely is one of these worthwhile additional complications. Unfortunately, it will be more complicated, so if you're still struggling with lists and tuples, you need to get back, you need to do a lot more work on lists and tuples and functions because this will be more complicated as a result. If you're struggling with lists, this will probably be like beyond what you'd want. However, if you're pretty good at dealing with lists of things, then this will end up making your life considerably easier. Okay, the way this is going to work is, okay, first of all, just full disclosure, the material that we're covering this week for dictionaries is not part of the midterm. Okay? Normally what we would do is we would use this entire week as review, and then we'd have a midterm on the weekend. Okay, but I'm assuming you don't want a midterm this weekend, right? Because otherwise we'd have to change everything. And no, so it's going to happen afterwards. But it doesn't make any sense for me to do a review right now because we don't have a midterm for like 3 more weekends. So it doesn't make any sense to do that. And sorry, I can't review for 3 weeks. Okay, we'll never finish our material. All right, so a little bit funny. We're going to do this, but it's not going to show up. Unfortunately, you won't see it in the labs even for a couple of weeks, which is really too bad. All right, so here we go. We're going to go forward with this. Anyway, this has been broken up into 2 different lectures. Really, I think there's something missing, which I'm hoping I'm going to be able to do today. And then I'm going to take what I've done. I'm going to shove it into the slides for next time, because I think it's a really good way to go about this. All right, so it's called Basic Dictionaries. Okay, I'll make it a slightly less basic towards the end, and then we'll actually see something useful for it. Okay, so the usual thing, there will be some sections out of the textbook, okay, and that's fine. All right, let's get this out of here, and I will run through the stuff as we, well, I might as well start with these examples. Okay, here we go. So let's drop this in place, and I will get rid of my doc. Go away, and I'll make this a bit bigger. Okay, here we go. Maybe just a touch too big right there. I hope that's big enough. All right, so what we've got here is we've got ourselves a class list, all right? And we have, of course, well, it is a list because of the square brackets, and inside, for whatever reason, the person has decided to use a nested list to store a bunch of information about what appears to be a bunch of students. The only reason why we think it might be a bunch of students is because numbers like 600 kind of suggest their ID numbers, but that's only because we're here. The next thing certainly looks like the name of something, and if we had to take a guess of what the 3.4, the 2.3, and the 3.2 is, you'd probably say it's a GPA, and yeah, that's pretty fair to say that that's probably what it is. I mean, we don't know for sure. I suppose if we left a comment somewhere, then we would know for sure. All right, second thing that happened is whoever decided to do this decided to use list of lists. They could have also used list of tuples. It would have been fine. All right, let's solve 2 problems using this list. Okay, so this is our review part. Okay, because both of these are going to have some issues. All right, I'm going to solve both of these problems by writing a very quick little function. I'm not even going to write up the doc string for it. I know I'm supposed to, but here we go. This is what I'm going to do is I want to be able to get the name of a student given the student ID. Okay, so here's what I'm going to do. I'm just going to say return not yet, as in I haven't actually implemented it yet. Okay, and down here, I'm going to ask for a student ID. I'm going to ask the user, input, enter student ID. Okay, and what I want to do is I want to get the student name by going to the function called getName, and I'm going to pass in at the student ID, not student IT. Okay, and then I'm going to print the name of the student. All right, I know it doesn't work, but if I type in 600355432, oh yeah, I said it's not going to work. Don't worry about it. Okay.
The value you student ID.
I said don't worry about it. It's not going to work. Okay. All right. Yes, okay, yes, we know we got some mistakes. We'll fix them. Okay. What should be displayed when I press enter? No, I'm not saying what's going to happen. What should happen?
What should happen?
Yeah, what name should appear? Hamid. Okay, good. This is what I'm looking for. All right, and if I type this, error? Maybe be a little bit more polite rather than a big red crash. Maybe a message like student not found? Nothing. Or maybe nothing. Just printing nothing is really disturbing because then it just looks like your program doesn't work.
Yeah.
Okay, printing a message to say, yeah, it's not there. Okay, that's what we're looking for.
Yeah.
Now, obviously, yes, I know we have some issues in here. Obviously, if you run this, bang, because I've misspelled some things. Yeah, that's fine. Okay, so here we go. That's obviously our first one. But you know, nothing is going to work yet anyway because, okay, 6003 5432. I should have typed that one easier. It says not yet because, well, I haven't implemented it. All right, so let's implement it. Okay. Do we have the data? Well, we do have the data. It's in this variable right here. Do I have access to that variable from this function? I do have access if I really want it. Because remember, right here, print. Can I say print class list? Okay, here. Can I print? Oh, sorry, not if you do that. Sorry, I have to type an integer. Yeah, I have access. Why? We talked about this. We had an entire lecture about local and global. Yes, I would have called it variable scoping. And you have access to the global variables. Now, should we use global variables? And the answer is no, we shouldn't be using them, but we do have access. All right, so here's what we're going to do. Instead of actually using those global variables, even though it works, here's what I'm going to do is let's have the full list. Oh, let's call it a C list. I really hate you. Okay. I don't want to call it class list because I've already got the class list. I just want to use a different variable name. All right, so here we go. We've got this pile of C lists. Okay, let's start writing this. So what would I do? Well, the usual thing about how if I was looking for one student out of something, here's what I would do. I'd set up a loop. Okay, and I'd say for X in C list, okay, print X. Okay, now, we've talked about this before. It's really not the best. I'm going to change this ID to be 33333 because it'd be a whole lot easier for me to type. Okay, please stop. Please run. All right, so 60033333. All right, so what's going to happen is this is going to go through and it's, oh, okay, missing a parameter. Oh, C list. Right, because here on line number 19, I'm supposed to pass in the class list. Okay, so here we go, class list. All right, try it again. 6003333. All right, good. I'm seeing everything. This is always my first approach, is just print everything. Okay, yeah, I know it's not solving our problem. Yeah, okay. Instead of calling it X, maybe we could call this, well, I mean, each one of these things is an X. So what would you describe that as? I'd probably describe each of those lines as being a student. Okay, so for each student in the class, 600, okay, it doesn't even matter because it's going to print everything. All right, so there we go. That's our first thing. But obviously, we're not interested in printing everything. We're only interested in whatever the user has typed in. All right, well, how do we pick this up? Well, remember, each one of these students is really a list, and I'm interested in just matching up the very first item. So instead of printing everything, I would probably have a statement like this. If the student in position 0 is equal to the student ID, okay, let's print the student. Again, still doesn't solve my problem, but 60033333. Yeah. Okay, well, we find that out. Here we go. Okay, there we go. Is that the student I'm interested in?
Yes.
Yeah, okay. Obviously, printing it is no good. You want to send it back. But do I want to send back everything? Take a look at what the function is called. What is the function called? Get name. What should it return?
Only the name.
The name, yeah. Should it return a whole bunch of other things?
No.
No. it should return just the name. If it was called getStudent, maybe we could return the entire thing, but it's called getName. Now, you don't need to make these decisions in our course, because what I will do is I'll come in and I'll say, please write a function called getName, and what it returns the name. Okay, so I'll actually do the design work for you. That's something that requires a little bit more advance, but I'm not interested in printing it. I'm interested in returning it. But as we said, we're not interested in returning the entire thing. We're interested in returning just the name part. So there you go. The name happens to be in position number 1. Okay, so if we do this, 6003333. Okay, there we go. There's the name. Okay, perfect. And what about something that doesn't exist? Well, right now it just says not yet. And the reason why it says not yet is because it went through everything inside, it never found anything, and it said not yet. Now, at this point here, what I would probably end up doing is I would probably have said, please return none if something is not found. And then what you would do is you put in print statement out here, and okay, here, let's run it. And you would say, if name is equal to none, then you'd say student not found. Okay, I'm going to leave this one out for right now. All right, so there we go. There's our first function. Okay, excellent. We could easily add some other things to it. Okay, like for example, I was thinking about doing an average GPA. Okay, there's a bunch of different ways how to do this. I just don't want to run out of time. So we'll stop at this one. But here we go. Before we start and actually ask the user, now remember, we don't have programs that are this big. We have programs that are really, really big. And of course, you know what's going to happen over time is new students are going to be added to my class list. So let's add a new student. Okay, so how do you add something to an existing list? Append, very good. Class list dot append. Okay, 6001111. Okay, what do you think? Is that adding a new student to my list? No. Well, I mean, it sort of is, but it's not really going to be correct. Just let me run class list, just so you can see it. There you go. So do you see the new student ID? Yes. But the problem is it looks completely different than everything else. Okay, because it's missing the name of the GPA. In fact, if I try running this program right now, and I ask for something that isn't there, I hope that's not there, shouldn't be. What should this do? Well, it should obviously return back none, and that's of course what it's going to print. A real program would say it isn't found, but unfortunately it blows up. And the reason why it blows up is because, well, it says right here that int object is not subscriptable. Now, if you immediately get this and you go, I don't understand what's happening, okay, this is the way how you debug things. This is what I do as well. Okay, remember what I had earlier? I was just printing everything. Print student. Yeah, don't be ashamed, just temporary. All right, but take a look at this. If you type in this thing, take a look. You see the first line, the first student that we found in the list was Ali, then Ahmed, then Amal, then Fatma, then Hamid. But then that next one, well, instead of being a list, it was just a single integer. And remember what I asked for. I said if student at position 0 is equal to the student that we're searching for. But the problem is that if you take an integer and you try to subscript 0, well, that makes a whole lot of sense about why it's not subscriptable. Okay? Oh, sorry?
I forgot what subscriptable.
That means that you can use the square brackets to gain access to the individual items.
Okay.
Okay? So strings are subscriptable, lists are subscriptable.
Okay.
Tuples? Yeah, because you can say tuple at a certain position. How about sets? No, because there's no order to them, so there's no index. Okay, so it would be non-subscriptable things. Plain everyday types are also non-subscriptable. Okay, so here we go. We've got this. So yeah, we obviously need this to be a list. Okay, we need a bunch of things. We need the student ID. Okay, we need a GPA. And we need the name of a student to go in there. People shaking their heads. Okay, well, let's go for it. I mean, I certainly see all the information, so here we go. All right, says none. Ignore the print statements. Okay, but yeah, it didn't find it. Okay, excellent. And if I ask for 60023, sorry, 33333, because that's the easy one. You see, it prints out Hamid. Again, just ignore the print statements.
Okay.
Okay, because it's actually there. But of course, then the issue is if I look for 60011111, it says that the name of that student is 3.3. All right, the reason why it says that is take a look at the print statements, and you can see how the print statements are really, really helpful. Remember, what we're doing is we're checking the first column. If the first column matches what I'm searching for, then I return the thing in the second column, which happened to be the GP. Oh, wait a minute. It's supposed to be the other way around. All right, and you say, yeah, but nobody's going to do that. Okay, I can bring up all kinds of examples of things that people are not supposed to do, and trust me, it happens. Example today. Okay, I know somebody was asking, so this is my funny business for the day. Well, it's kind of annoying, but anyway, it is kind of funny. Let me see if I can find the image. All right. We were about to switch over to having all of our grades put in D2L and will automatically appear over in PeopleSoft. One of the things that we were told to do was to make sure that everybody has an entry called cumulative midterm grade, spelt exactly like that. Okay, it has to be spelt exactly like that. As of this morning, this was the variations of stuff about how people have spelt it. Cumulative space, mid space, term space, grade, that's correct, but the next one is cumulative midterm grade with a small g. Guess what? That's not going to work. Cumulative midterm grade space at the very end. How do you get rid of spaces at the end in Python? No. How do you get rid of them? Strip. Strip is the name, okay? Strip is the name. It gets rid of the new line characters and the spaces at the end. They didn't use this one in D2L. We have cumulative midterm grade. We have cumulative midterm space-based grade. You see the types of problems that happen when people type things in? The same thing ends up happening in here. So you might say, yeah, but it's pretty obvious. When you get a lot of data, it's really not that obvious. Okay? All right, so there we go. That's a simple thing. That's out of the way, and that's the old approach. Okay, what I would like to do today is to introduce a brand new data structure. We're not going to be able to solve this problem today, but I will be able to solve the next class because we're just run out of time. All right, so here we go. Let's get rid of everything, and we'll bring up a new data structure. Okay, so make it simple. One student. One student, here we go. Ooh, okay. Now, unfortunately, I'm switching over to this. I might as well use the same names that I had here before. Okay, here we go. Ali, 60012 3 4 5 and 3.4. Okay, it's a little bit of a different format. Here we go. Here we go. Print out the student. There you go. Now it's back into its regular format. So just one student. Make it as simple as possible. What type is student? Not a trick question. It's a list. Okay. All right. And we've talked about if you want to access the individual items, student at 0 in this case will give me the name. Student at 1 would give me the ID. Student at 2 would give me the GPA. But of course, it's different than what I had just a few minutes ago. That's fine. It's a different setup. So as a result, maybe we got something a little bit different. All right. Next one up. Could we turn this into a tuple? And the answer is sure. That'll just turn into a tuple. Remember, there's no difference except that you can't change anything. Okay, do you want your GPA fixed and not changing?
Fixed.
If your GPA is high, then yes, you want it fixed. But if your GPA is low, you obviously want to be able to change it. This is not really the most appropriate data structure for it. All right, we also learned about something called a set. Okay, although this would be completely valid, I don't think it really makes any sense because if you wanted the name from this person, how do you get the name? Okay, because you can't ask for position 0 because it doesn't exist. I guess you could iterate through until you found a string, but there could be other strings. It could be like addresses stored inside the student. Yeah, this is completely inappropriate. However, there is a new type we're going to look at today, very, very important, and it's called a dictionary. We saw this the other day. Okay, so let me do a print type student. If I run it right now, it's a set. I'm going to turn this into a dictionary because remember, if you just use the curly braces that said it was a dictionary, here's how you make it a dictionary.
Empty
Okay. What you do is you put the name of a property followed by a colon. Okay? The name of the property followed by a colon followed by the value. All right, so the very first thing is clearly the name. What would you call this thing right here? Student ID. There we go. I'm going to call this student ID. Ooh, we'll come back and we'll talk about changing the names of these things. And what would you call this one?
GPA.
There you go, GPA. In order to be consistent with my naming, let's call it student ID and name. Okay, that is a dictionary. Okay, so let's go ahead and run it. Okay, clearly is a dictionary. All right, so, but wait a minute, a dictionary is that thing that you look up descriptions of words. Yeah, that's actually where they get the idea from. You see, in a dictionary, what you have is you have a whole bunch of words. Those are called the keys, and then the definition is the value. Here, it's exactly the same idea. So the student has a name, they have a student ID, and a GPA. Okay? So we're making it very, very clear. We're actually labeling the individual properties rather than just making a list and hoping that we keep the order the same. Yeah.
If this is a dictionary, why did it show dictionary when we had two curly brackets and an empty space in between them?
Because that makes it an empty dictionary.
Empty dictionary.
It's an empty dictionary. Has nothing in it.
Okay.
Okay. Now, why did they use that for sets? I don't know. But anyway, so there you go. There's a dictionary. Now, the cool thing about this, okay, so here's the idea, is a student has a bunch of properties and a value that goes with each of the properties. Okay. Now, obviously, when you run this as a print, okay, so we know it's a dictionary. And when we print it, okay, we can see what are called the keys and the values. So the keys are name, student ID, and GPA, and the values are Ali 60001 2 3 4 5, and the GPA, or sorry, the value is 3.4. Okay, so that's fine. What's the point of this whole thing? All right, if I want to get out very, very specific information about this student, for example, if I wanted to get just the GPA, here's how you do it. You use square brackets, okay, just like a list, but instead of putting a position like 0, because if you try this, that blows up. You have to always spell it correct. Here we go, print. All right, it says it's got a key error. Okay, we'll come back to a key error in a second. Okay, it's not this one, but this one right here. If you're looking for the student's GPA, here's how you get it. You simply list the thing that you're looking for. All right, when I run this, it gives me exactly the 3.4. Okay, now, here's where the really cool thing is, because if I take this one out here, sorry, control GPA, because I'm undoing the wrong thing, sorry. If I take this one right here and I put it, maybe I made a mistake and I list it first, it's completely fine, it still works. So print the student. If I want somebody's name, it's no problem. It's like this. Okay, and if I'm looking for the student's student ID, yeah, I'd probably just use ID. That's way too much typing. All right, there we go. And the order is completely unimportant because what I'm doing is I'm asking for something at a given position, but a position this time doesn't mean the location in the dictionary. It means the associated key. And that's really important because when we go back to our previous problem, somebody comes along and they put a brand new entry in my list and they put the order backwards, doesn't matter. It absolutely doesn't matter because if I'm looking for somebody's name, it's going to be called square bracket name, not square bracket 1, but square bracket name, and it doesn't matter where it appears. Now that's really, really, really neat because it allows us to be able to find things without having to know the exact location of things. So that's really important. However, obviously there's going to be some other things that are going to pop up that are going to cause us some trouble. So here we go. Let's try to create some trouble. Okay, so for example, okay, somebody comes along and you say, okay, give me the phone number for this student. Yeah, there's no phone number. Okay, good answer. What happens when I run this piece of code is I get something called a key error. Okay, the whole program crashes, and it says, well, this particular student doesn't have a phone number recorded. Okay. Obviously, before we do this, we would need to know whether or not there's a phone number in here. Okay, so again, unfortunately, we've got just one student. Well, maybe fortunately. So let's actually try this. Let's find out whether or not there's a phone number. Luckily, it's using something that you've seen before. Okay, and here we go. Here, I'll use this as an if statement because this is normally what we would do. If phone in student, okay, and of course the in operator in a list tells you whether or not something's in the list. This is exactly what it means inside a dictionary. So if the phone is in the student, then we'll print it. Otherwise, no phone number. There you go, no phone number in that student. Okay, well, let's go ahead and add it. Where? Well, it's completely irrelevant where I put it. As long as it's called phone, it'll be perfectly fine. So you see, now it actually has a phone number. Okay, so that's pretty cool. All right, so we can use an if statement to find out if it has a property, and once we know that it has a property, we can just go and we can refer to it as student.phone, student.whatever property we're looking for. All right, so that's fine. That's for pulling data out. Okay, well, let's go the other direction then. What if we want to change what we've got here? So here we go. We've got this. I suppose if you are that student, you probably want your GPA updated, so let's change your GPA. If this was a list, remember that you can do things like this. I mean, we were doing this all along. Test score, position 099. Okay, well, guess what? If you try something like that, you're going to get some weird results. I'll show you that one in a minute. Okay, I'll come back to this one. Okay, because that's a little bit different. But if I wanted to change the GPA to 3.6 from 3.4, what do you think I use in here? Yeah, GPA. Oh, what if I just used GPA like this? I might as well make that mistake. Then we're going to print the student. Yeah, it's an error. Why? No, not quite.
Because GPA is an variable now.
Yeah, it's a variable that doesn't exist.
Yeah.
Okay, so yes, that would actually say, hey, I don't have a variable called GPA.
Yeah.
Okay, so that doesn't mean that you, it doesn't mean that it's always a string. Okay, there's going to be lots of reasons why we might not always use a string, but for today's exercise, yes, if you actually want to change something, this is what you do. All right. I'm going to print the student just before changing the GPA. I'm going to change the GPA and print it afterwards because I just want to find out did it work. All right, so did the student's GPA change?
Yes.
Yeah, okay, good. It went from a 3.4 to a 3.6. Okay, that was pretty easy. All right. What if I misspell it? Now, a few minutes ago, when I misspelled something when I was trying to read it, I got a key error.
Yeah.
Okay, so it sounds pretty reasonable. We're going to get a key error here as well. No, we're not. Okay, what this ends up doing is if you try to set a property of something that doesn't exist, because maybe you misspelt it as gap instead of GPA, it happens to everybody, what it does is it adds a brand new property to that dictionary with a new key. It doesn't provide a warning. It doesn't say, oh, it doesn't exist, sorry, crash. No, it just carries on and works incorrectly. Okay, that's nice. Program doesn't crash. No, that's actually not a good thing. In a lot of cases, if you have a bug, you actually want your program to stop.
Yeah.
However, it's just something you have to be aware of. Okay, so in other words, before, obviously you just have to be careful on your typing. If you're actually hard coding these things, well, don't misspell the property names. I mean, I guess that's the clearest thing. And since we're here, and I almost ran that earlier, what do you think happens if I do this? Well, surely that's got to be an error because there is no position 0. Okay, here's the result. It did exactly the same thing. It created a brand new property or brand new entry in my dictionary where the key was equal to 0 and the property and the value was 3.6. Okay, so just be careful about that. I asked lots of questions like this on the tests of some of our tracing stuff. Obviously not the midterm, because I said that this is not part of it. Okay, but you have to be kind of careful about these types of things. Okay, so why use dictionaries? I'm just looking to see what's coming next. Okay, I would like to switch over and actually give you a real problem involving something that looks kind of like dictionaries and something that looks like without dictionaries. And here's what I'm going to do. Okay, I gave ChatGPT a whole bunch of our program code just because it was really horrible to type this in. All right, and he came up with a list of courses. So these are a list of all the courses that one must take if you're taking the degree in INFS. Okay, so these are all of them. I didn't bother with electives and so on. I know there's different things, but here you go. This is a huge structure. It's a list, and inside the list, I've got two entries. I have the course code and the name of the course. I want to do a couple of things. Okay, the first thing up is I want to know how many courses I've got all together. So I'm just going to write some programs that'll be down here at the bottom. Okay, we don't even need to scroll up very much. Okay, we'll just print it down here. If I wanted to know how many courses I've got, okay, it's called course list. Courses list. Stupid thing shouldn't be plural. Shouldn't be plural. Should be course list. There you go. There's a list of courses. How many are there? Okay, nobody wants to count that. Okay, how do we actually do this in code? How do you find out how many things are in a list? You have to know this for the midterm. Yeah, Len. There you go, so there's 52 courses. Hey, that's pretty easy. All right, let's go and pull out the name of one of the courses. So let's suppose we know that we've got a course we have to take called, let me pick one out here, INFS 3103. Okay, most of you won't have to worry about that unless you happen to be in the INFS program, but I want to get the name of the course for INFS 3103. Now, look at the structure of what I've done here. It's a bunch of tuples. For some reason, they've used tuples this time. Could be in square brackets. Could have been dictionaries. Yeah, but that's nested structures. I'm not allowed to do yet. Okay? Well, actually, I mean, we've already started on this. All right, so here's what I want to do. I want to go through and I want to be able to do a search for 3103. And just to let you know, 3103 right here, system analysis and design. Okay, we'll get to that. But what we're going to do is we want to go through and we basically have to do a search for everything. Okay, we've been through this a whole pile of times. For X in courses list, print X. Okay, there's everything. Now, what do I really have here? X is not a very good term. What would you describe each of those lines as? What do you think? So if I said, what is that? Give me a name of a description of it. Yeah, of course. Okay, so it's one particular course. So, all right, because I'm incredibly lazy, CRS. CRS. Okay, there you go. So an individual course. Each individual course is actually comprised of two things because it's a tuple. What do you call the first part? Code. Okay, and what do you call the second part? Course name. Course description. Yeah, course name. That's fine. All right, remember I have this really cool little trick. Because these are tuples, I can actually use something like this. I can use code and name. And I can pull out code and name. Okay, so there you go. There's the code and the names. Okay, again, I talked about using tuples, and this is called tuple unpacking. All right, so here's what I'm going to do. I am going to ask the user for a code, so I'm going to call it the search, and I'm going to say input, enter code, and the user's going to type in a code, and I'm going to do the following. I'm going to say if code, which is coming from my list, is exactly equal to the search, then I'm going to print just the name. Okay, here we go. INFS 3101. Oh, sorry, it wasn't 3101. It was a different number, 3103. Sorry, run it again. 3103. Oh. Isn't working. Okay, what do we do? Well, you debug it. Print search code name. Okay. Oh, missing INFS. Happens. Okay, here we go. INFS 3103. Okay, now unfortunately, it's kind of a mess because we're printing everything, but you notice right here, there was something at least a little bit different. I think that's the founded. All right, so now let's get rid of my print statement. Hey, print statements, really good for temporary stuff. INFS 3103, system analysis and design. Hey, good. It makes it really quick to look these things up. Okay, let's try one extra one. We'll try something right at the end. INFS 4206. I know I can see it right there. It's native app technologies. Okay, perfect. There you go. And by the way, this is completely fair game with the upcoming midterm stuff like this. Yeah, iterate through looking for something. Okay. Now, of course, what you would do is you put it into a function and return it. But hey, it's I mean, there's nothing off the wall here that we've done. Okay, so this is fine. We've got ourselves a list of something. So you know to find things in a list. You start at the beginning. You go through and you exercise everything. All right, I would like to turn this problem into a dictionary problem. Okay, so erase everything. Somewhere in here, I've got the equivalent of a dictionary. Okay, there you go. So my courses, sorry, I didn't want to call the courses list because it's not a list anymore. You can see it's got the curly brace, so it might be a set, might be a dictionary, but because I've got the name followed by, or sorry, the code followed by a name, say this is called a key, this is called a value. That is a dictionary. Okay, so it's a dictionary. It's a little bit different because previously I was using the keys as being different properties of something. But now what I'm doing is I'm using the course code as being different properties. Now I suppose something which I didn't talk about when we're dealing with the student is, can you have two properties with the same key? And the answer is no, you can't. They have to be unique. Yeah. Okay, you can't have a student with two names. Well, you could call it name one and name two, but you can't have a name and another name. Because if you try to assign a different name, it would erase the first one, which was what we did when we had the GPA. All right, so now this is kind of cool because COM1010, there's only one course with a code called COM1010. This works really, really well for dictionaries. And here's what I'm going to do is I want to come down here and I want to print a couple of things. Okay, so just like what we were doing before. If I say print the courses, okay, it prints absolutely everything. That's a complete disaster. I'm not interested in looking at that. But remember what we were trying to do. We were trying to find INFS 3103. Okay, now you think about what we've got here compared to what we had just a second ago. We'll put it back into the same type of program. Remember how this worked. I had search, and I said to the user, enter the code, and instead of looking up directly, I'm just going to take the variable and I'm going to put it in there and I'm going to print out whatever the name happens to be. Now, this is incredibly, incredibly powerful. So here we go. Math 1030, okay, also known as Calculus 2, or sorry, Calculus 1. Yeah, that was easy, okay. INFS 3301, human-computer interaction. Now, think about this from a programming point of view. No loops. That's powerful. Okay, you didn't have to set up a loop. You didn't have to put it into tuples. You didn't have to break it apart. I just went directly in and I said, okay, give me the value given this key. And that's actually really cool. Not only is it easy, it's actually really fast too. It's just as fast as the difference between the list versus the sets I showed you the other day. Okay, so this is really, really neat because it allows me to look up things without having to set up a loop. And that is very, very handy. Okay, because as soon as you make a loop and put in if statements, well, the more code you write, the more problems you're going to cause, right? I mean, that is true. I mean, if you can get away without writing anything, you won't make any mistakes. Of course, you won't get any marks in the course, but you won't make any mistakes. But one of the things that you'll find when you carry on, you do the DSAI 2201 course, you'll actually find that there's so much stuff built in like this, you'll actually forget anything to do with programming because you're basically running one statement at a time. All right, but in any case, here we go. Let's run this, and we search for INFS 2222, which, by the way, is not actually a valid course. What does this tell me? Okay, so what's going to happen is it's going to say find the courses INFS 2222. It doesn't exist? Yeah, it's a key error. Okay, ooh, yeah, because it doesn't exist. What you need to do, sorry, you can't avoid the if statement. You'd have to ask, is the search in courses? If it is, then you can print the course. Otherwise, you could print course not found, course not found. Okay, so there you go, course not found. But still, DAX 2201, I know that's in the list. There you go, it's Introduction to Data and Cybersecurity. Okay, again, pretty cool. I mean, we didn't avoid the if statement, but at least we got rid of the loop. All right, and yeah, loops were always the things that caused people a pile of trouble because you have to look for patterns and so on. Sorry, you're still going to need loops. This isn't the magic solve all. Sometimes you need this, sometimes you get away with it, but there's going to be lots of times where we need lots of other things. Okay, let me just take a look to see what I've got. I am actually covering all the material, just not exactly in the same order, so just be patient with me. Okay, that one we'll deal with. All right. We have to learn about some extra things. Okay, first of all, how many courses are there? We know the number.
52.
It was 52. Okay, how can I make this appear here? Now remember, if I print courses, that's going to print everything.
Yeah.
How do you think I figure out how many courses there are? Yeah, exactly the same. Okay, it's the same function as you use for finding out how many elements are in a list, how many elements are in a tuple, how many elements are in a set, how many elements are in a dictionary. So at least it's useful. But you have to be careful because this is one element. Okay, sometimes students will look at that and say, no, that's two things. No, no, that's one thing. Okay, it's a key value. Dictionaries are key value pairs. That's one item. So if I remove everything else except for that first line, the length would be exactly 1. Okay, all right, and that's number 2. This is number 3. I put them on different lines. It doesn't matter, by the way, same as before. I can put them across in a single line. Everything still works the same. It just makes it a little bit harder to read. Okay, so I'll leave it like this. Okay, so that's the first one. Okay, next one up. All right, what other types of weird things can we do with, say, lists? Stop this. Okay, sometimes my editor gets a little out of whack. Here, let's push this down here. All right, let's see. We learned how to access an individual element with a square bracket. We already know how to do that. When we think about lists and tuples and sets, I always showed you what does it mean to go through each of the items. So we better talk about this. Okay, so that is called iteration over a dictionary. Is that possible? Okay, well, it certainly seems like it's reasonable because obviously there are many things. There are 52 things inside here. And I guess the question becomes is if you iterate through them, what do we see? Okay, I don't know what to call it yet, so I'll just call it X, but we'll change this with a name in a few seconds once we see it run. Okay, so here's what happens if you use a for loop. And by the way, it does work. This is what you get. Okay, so what are those things? Well, remember, a dictionary is filled with keys and values. The keys are the things that show up on the left-hand side before the colon. The values are the things that show up on the right-hand side. What am I looking at here? Keys. Yeah, that's it. All right, so this is what you get. When you iterate through a dictionary, you only get the keys. What if you want the values? Because often you want the values. Okay, well, unfortunately, if you want the values, okay, so here you go. I suppose you could call it the keys, but I really don't like the word key because this actually has a meaning in my problem. And that happens to be that it's a course, here we go, course code. Or maybe we'll just call it code because we're lazy. Okay, so code, print code. That's the course code. Okay, if you want, what's the value? Well, the value is the name of the course. If you want the name of the course, so I'll call it course name. What I would have to do is I go to the courses, remember that's the full dictionary, and I could ask for the thing that's at the given position called code, because that would be at a given key. And we know that it exists because we're iterating through. So take a look at this, course name. So that's the code, there you go, that's the name. So now I can see everything. So the reason why you might want something like this is imagine I want to change my program a little bit. Okay, so here we go. I want to search for something. I'm going to ask for the user to enter name of course. All right, and here's the idea. When you run this, somebody's going to type statistics, and I want to see math 1040. Okay, so that happens to be the code. Of course, right now it's not doing this, just printing everything. All right, so here's what I want to do. I want to just print the math 1040 because I typed in statistics. Well, remember, that's not the key, that's the value of the dictionary. If we go the other direction and the user types in the key, it's really easy to find the key, but if you type in the value, unfortunately, the only thing you can do is to iterate through all of the items looking for the thing that matches. So here's what you would have to do. You would have to, not print it, of course, you'd have to start asking questions. You'd have to say, okay, if the course name is equal to what we're searching for, then we can say that we found it, and we'd probably print the code. Okay, here we go, statistics. Oh, that doesn't exist. Statistics. There we go, math 1040. Yeah, unfortunately, you have to spell it very, very carefully. Native App Technologies. There you go, infs1201. That happens to be the last one we put in here. Don't ask me to type the other ones, because obviously it's hard to type things exactly correct, as I showed in the earlier example. Okay, so here's kind of a really important concept. Given a key, it's really easy to find a value. Given a value, you can find the key, but you have to iterate through looking for things. It's kind of like the old style. When you take the course called infs1201 Database Management Systems, please remember this. When you do a search on the primary key, it's very, very quick. When you do a search on any other property, it's going to take a long time. You have to look at all of the values, which is exactly what's happening in here. Okay, so but that's not important for there, but it is important here because it's that type of question that I like to ask on tests. Not can you look up something by using the square brackets, but having to iterate through looking for things this way. Yes?
If you store an item in the key, can that item become a key? Can you use the same item to make it a key also, like a key value? So the English communication.
Okay, good,
can that
good.
be used as a key?
Yeah, okay. What I could do is okay, excellent. I could do this. That's an interesting idea. It would be horrible, but it would make a really nice question. Thank you for the idea. Okay, so here is the suggestion is, what if, could I do something like this? Not with question marks. Stop it. Okay, it's a very interesting question. Actually, nobody's ever asked that one. Could I do this? And the answer is, of course I can do this. That's allowed. Okay. But here's the problem that I have with it. Okay. Oh, and by the way, this would work perfectly fine. If somebody does a search, okay, here, might as well prove it. Okay, if I print courses at com 1010, that was the one. Sorry, I'm confused about what I've got to type here with my fingers. There you go. That's this one. And I could also print courses at, okay, here we go, English Communication 1. Oh, single quotes, double quotes, by the way, works. And yeah, I could use it for both. Okay, would I ever do this? No. Okay, why? I'm a firm believer that in any type of a structure, you should always be keeping the same types of information. Okay, and yes, you'll say, well, it's a string and a string. That is true, but what you're doing in the first part is you're storing the codes, then the names, then you're storing the names, then the codes. Okay, you can do it, okay, but you wouldn't want to, okay, because it'll make the programming very, very difficult especially when we start to add extra fields. You see, what I don't have right now is the number of credit hours these things are. I don't have the prerequisites listed. Okay, and you flip these things around. Actually, that's exactly the technique. So again, works out well for the database course. When you learn about indexes, think back to this lecture, because that's basically what we're doing right here. We're creating an index, okay, where we are saying that English communications is equal to this. You could do it. I would never recommend doing it, okay, and I don't think I would make you do it, but it's a really interesting problem, okay. What I suppose you could do is say, here's a list of all these things. Now, store all the values yourself, not by hard coding. Okay, and you'd have to take each of these and flip them around. It's possible. It would just be really awkward to use. All right, let me get back over to here because I've got some more things I have to do with for loops. Okay, for x in, okay, courses print x. I guess the question is were you awake a few seconds ago? What do I see when I run this program? Yeah, I see the keys. Okay, very good. All right, get ready for this one. There is a function on a dictionary called values. Take a wild guess what it does. Yeah, it's all the values, but not the keys. Okay. All right, so I mean, this can be useful if you're looking to find out if statistics is there. Unfortunately, it doesn't tell you what the code is. Okay, but at least you can tell if something is there. So if you need to iterate through all the values looking for things, this is a really good way to do it. All right, get ready for this one. This one will knock your socks off. There's also something called keys. And guess what it sends you?
The keys.
The keys. Oh, but you have to spell it correctly, sorry. Oh, hit the wrong key. But that looks exactly the same as the first one, yeah. Just an extra thing, okay? Okay, why would you do this? There's kind of some clever things that you can use with the dot keys, and here you go. This might be one of the reasons. Let's see, codes is equal to courses dot keys, print codes. Let me cover up that one. There you go. It's a bunch of dictionary keys. Basically, these are like sets. Okay, this is basically a set. Most of the time what I would do is I would probably take these and I'd actually typecast it into a set, and there you go, it's a set of keys. You're guaranteed there's no duplicates because keys are never duplicated. That's sometimes what we use the dot keys for. But then again, it also does the same thing without it. So it's kind of a redundant term. I believe what happened was somebody made the dot keys first, and then they said, let's allow people to be even lazier and remove the need for it. Okay, let me get back over. So the dot keys, it's there, but it's kind of silly. But this one is kind of useful. There's another one called items. And what these are, these will be all of the items in the dictionary. Okay, now take a look at this. I think you recognize this one because we started with this in the first place. Yeah. What this is, this turns it into a tuple where the first thing is the key, the second thing is the value. So quite often what we'll end up doing is we will have code and name. There you go, and code and name. There you go. So now we've got this. So now we can do something like this. We can say if code is equal to our search term, then you can print, I don't know, say the name. Okay, and what we'll do is I'll just say search is equal to DSAI2201. There you go. So obviously ask the user for this. Okay. Is it any different than what I had before? No, it's just different formatting. No more power, no less power. It's just convenience. Okay. My only recommendation if you use courses.item is please unpack the tuple and actually give them meaningful names. It will make the problem a whole lot easier to solve and work with. Okay, what else have we got in here? Oh, okay. Okay, we'll get a couple of things in here that I've skipped. How are we doing? Okay, we're good for time. Print code name. All right, that's not difficult. That simply prints everything. Okay, people don't like things, right? There's certain courses people don't like, so let's get rid of courses that we don't like. Okay, which course would you like to get rid of? Oh, there's a hint. DEL for delete. There's a few different ways. All right, what course do you not like? Yeah, you want to put 1201. But the thing is, if you don't take 1201, then you can't take most of the further courses. And I know if you're in FinTech, maybe that you can get away with. But unfortunately, if you're taking an IS degree, yeah, you can't. Okay, let's be a little bit more cynical. Let's get rid of statistics for some reason. Okay, but I mean, if you want to try this and remove 1201, it's fine. How do we get rid of things? Okay, well, as I say, there's a few different ways how to get rid of things. This is the way that I always use. You go to courses and basically you say, what we're going to do, let's say Math 1040. Okay, so normally Math 1040 shows up after Math for IT and before Intro to Data and Cybersecurity. And of course, if I run it now, you'll see that it is gone. And yeah, we do have to check things around because dictionaries, like sets, have no guarantee of order. Okay. I know everything looks like it's very, very well structured in here, but there's no guarantee of it.
Yeah.
Okay? There's absolutely no guarantee. It normally behaves itself and you'll see it in the same order, but as you start to add and remove things, you can get some weird business that happens. All right, so yeah, that's how you get rid of something. Pretty straightforward. It's just DEL. There are also functions built in. I think there's one called remove. I almost hardly ever use it. Okay, how are we doing? I think we're not bad. Let's take a quick spin through our slides, and then what I can do is I think I've probably got one of those rotten cahoots, if you want to try it, that has to do with nested lists. I also have one called sets and tuples, and I've stuck the word in parentheses difficult. So obviously that was my intention, was to make some tricky things. We'll do it just after the break or maybe next class. All right, let's skip through this and make sure we've got everything. So it is possible to use list of lists or lists of tuples to track things, but as I put here, the code can be brittle. What the word brittle means, it means that it's easy for somebody to break something. Okay, and this is not something we usually have to worry about in 1201, but as you start to put together really big systems, you may find that one part of your code does something and it causes other parts of your program to fail. And lists of lists is one of those cases because somebody may put the items in the wrong order because, well, they just didn't know any better. I mean, this type of thing does happen. So there's a bit of an issue with this because if we're expecting things to be in a certain order, well, they have to be in a certain order. And if they're not, maybe the program crashes. All right, and of course, as I say here, the program won't stop you from doing this, well, until something goes horribly, horribly wrong. So what we did is we introduced the concept of a dictionary, which is known as key-value pairs. Okay, and the key is like a label or a name. The value is whatever you want. These things go by different names in other languages. Sometimes they're called maps and associative arrays. Doesn't really matter, but it does use the curly braces and the colons to separate the keys into values. Okay, so to access the individual items or to update them, you use the square brackets. We've been through this already. If you try to access, you try to read a key, a non-existing key, you get a crash, versus what happens if you try to modify something, it actually goes and adds the new key. Yeah?
Shouldn't the key be string?
No. In fact, we saw that it doesn't have to be a string. We saw that it could be, in fact, an integer. In fact, that's an interesting thing. Okay, now everybody's groaning saying, oh, look, he started off in another example. Okay, well, that's fine. Okay, how long are different months? Okay, January is 31. January happens to be month number 1. February happens to be 28 days, except for those weird leap years. March happens to be 31 days. April happens to be 30 days. And so on, so on, and so on. I won't put them all in here, but you see what I can do is I can ask for month length and say I'm looking for the length of March. There you go, it's 31 days. It can save you a whole pile of if else, if else, if else, if else. Yeah, you can also just stick it into an array, into a list, and it would probably be a bit easier. But yeah, just to show you that they can be integers. They can be other things as well. They can also be, well, basically any immutable type. So they can also be tuples. And I never show in this course about why you might want to use a tuple. If I can find some use for it at some point, I will include it, but sorry, be patient. Normally I don't cover it. Okay, nice question, thank you. So they don't have to be strings. In this course, they're mostly strings though. Okay, they don't have to be, but most of them will be. Okay, and okay, so we've already talked about adding something. We've got why use the dictionaries. Okay, they're pretty quick. Okay, I showed the demonstration the other day of how quick sets were compared to lists. Sets and dictionaries have roughly the same speed. Okay, the code is considerably more understandable because if you take a look at print student 2, that doesn't really mean anything, but this statement right here, print student age, that's pretty clear what it's doing. Okay, it makes it very clear what you're doing, unless you happen to see this like just before, but even then, you still have no idea what the 21 means. Okay, it really does help the readability of the code considerably, and just for that, it's always worthwhile using tuples where possible. Okay, so keys must be unique. Okay, you're not allowed to have two with the same. So sorry, we need to come back here to a student. Okay, well, we had a student ID 6006 1234. We had the name. And what happens if I stick another ID afterwards with 6001235? If I print the student, just like what we saw in the world of sets, yeah, you'll only see one thing. Which does it take? Well, it takes the most recent thing that it bumped into. Okay? So it found the first ID, but then when it found the second ID, it replaced the first ID with the second one. Okay, so keys must be immutable. They can be strings, integers, or tuples. Hey, that was the question that we just had. Excellent. We were looking forward to that. The only thing is I haven't shown you what would it mean to have tuples. Okay, I would need a much bigger problem than what we've got, and not something I want to try to do right now. All right, so keys can be any other type, including more dictionaries. And yeah, when I say it can be any type, we're talking about the stuff over here. So take a look at this. You see the student now has a name, whose name is Alice, that's a string, but they also have grades. Yeah, grades. And that happens to be a list of grades. Not just one grade, but a list of grades, which means that I could do things like calculate the average of the grades. The profile, on the other hand, is even more interesting because that on itself is also another dictionary. Yeah, so we're talking about dictionaries inside dictionaries. Yes. So what this says, it says that, well, this particular student has a computer science major and they're currently in year number 2. Okay? Yeah, it's just a convenient way. Do I really need this? I could have had major and I could have had year as separate properties, but sometimes you merge multiple things together so that we only talk about the profile. Yeah.
And the same key, you can store different types of things like an integer and a string in the same key?
No.
No?
There's the same key, two different types. Second one overwrites the first one.
Oh,
Okay, yeah. Only one thing. As I say, if you want to have something like grades and you want it to have, say, a list of a bunch of grades, okay, that's something completely different. Okay, there you go. That's permitted.
Okay.
But you can't have two things with the same.
Yeah.
Okay. You could take the two values and put them into a list using the same key, or like what I've done here is a dictionary, but no, the key is the thing that makes a difference. All right, so checking for keys and removing keys. So I showed you how to deal with the if, and I showed you how to deal with the del. Sorry, I forgot to cover this one right here. Okay, we can do this one. Okay, this should only take a second. How are we doing? I got lots of time yet. Okay, not a trick question. Student name. Okay, what do I get? Ahmed. Okay, good. Student ID. 6006 1234. Student GPA. Yeah, key error. Okay, very good. Okay, key error, this one. But there is a function called get GPA. Okay, sorry, there's another function called get where you can pass in the name of what you're looking for. Okay, that's the same thing. If I ask for the name, what do you think I get? Okay, and here's the important one. If I ask for GPA, instead of a key error, I get none. Okay. Because I get a key error because I get none instead of a key error, it means my program continues. So if you just want to know whether or not something is there and you want it to be none otherwise, that's fine. And here's a second example. If I'm trying to get the GPA and the GPA doesn't exist, then I'll return a 0 if I don't find it. Sometimes convenient. Okay. Iterating of dictionaries. So I showed you what happens if you say for x in student. And I also showed you for x student.values, so you get the right-hand side. And of course, getting back the tuples of the key and the value works the same. And I said right here that there's also a dot keys, but it really doesn't gain you anything, but it's there just in case you ever bump into something and you say, hey, what's this other thing? It's not actually necessary. Okay, so there we go. That's the important stuff. That's all the stuff for the day. What I'm going to be doing in Wednesday's class is we're now going to have lists of dictionaries, because that is where things really become important. The first example with a single student with a bunch of properties, okay, I mean, this is really just to cover the concepts. It's not that useful, because really I could have just had 3 separate variables and I would have had the same power. Okay, the second one where I had a bunch of courses, that was kind of more useful because we were able to look up very quickly values given properties by just using the subscript operator. So really, really nice. But of course, it comes at a cost. If you're trying to find the value side, you have to iterate through everything, unless you do something weird like flip the dictionary around. Okay, and we have asked occasionally to do things like that. I think there's a lab exercise similar to it. Okay, but the real power doesn't come from stuff like what I've just done. It comes from having lists of dictionaries, and you're going to see a lot of activities in a couple of the labs where we do this type of stuff, because when you go to a database and you ask for a bunch of information from a database, guess what format it shows up? It shows up as a list of dictionaries. So these types of things, you need to know how to process them. So we focus a lot of time on how to process lists of dictionaries. It's nothing really new, but it's kind of a combination of things that we have seen already. Okay, so let me see. Over here, so we have our choice. We have one called nested list, and we also have something called sets and tuples difficult. What do you think? Nested lists or difficult sets and tuples? Difficult sets and tuples. Okay, so somebody's very, very brave. So let's see what type of crazy things I came up with. Maybe they're not that bad. Okay, and I think I found a way how to make these things available for people to play offline. I will have to put out a bunch of links. Okay, so here you go. This was in response to some students saying that all of the questions that they were seeing on these, we used to have these horrible self-assessments, practice quizzes and so on, but they were simply not hard enough. And they said, yeah, but the questions are too easy. So I said, okay, let's try some difficult ones. I think that's the reason why it says difficult. Okay, we got 14. Okay, let's see if we get a few more. Okay, for 20, one more. Anyone? Hey, 20. Okay, I think we better start, otherwise we will possibly run out of time, because we'll probably need a few minutes between each. Okay, here we go. I think one extra person got in. Okay, so let's find out what I meant by difficult. Maybe I just provided no time. 7 questions. Oh yeah, great. Okay, it's going to be difficult to finish everything. 2 minutes each? Yeah. Okay, well, we'll go till 3:20 and we'll have to stop. get 21 answers, we'll continue on. We're not going to wait for the full time. So 6 people are asleep or disconnected. Okay, 5, 4, 3, 2, 1. Okay, I think maybe there's might be 2 more. You can have a few more seconds. We'll proceed at when it says 30. Okay. Anybody else? I can't remember if there's 20 or 21. I think maybe 20. Okay, here we go. Next one. Okay, very good. So most people, of course, okay, a bunch of people went after the 10. All right, remember, it's the length of something of samples. So you have to call the function something. Samples, of course, is a list, but when you go inside the function, what we do is we set up a result, which is an empty set, and we go through and we add each of the items. Remember, anytime that you add duplicates, the duplicates are going to be removed. So that's why we end up with fewer things. Oh, see, it's easy. It's the same thing. Or is it? Oh, it's this doesn't seem all that difficult, is it? Okay, 3 more seconds. If you want to answer. Okay. All right, good. All right, somebody went after the actual set, but of course, remember, get rid of the duplicates, please. Okay, here we go. These weren't very difficult at all. Okay. Sorry? Oh, they're all missing a 5. Ah, okay. To look at that one. Okay, I'll make note of it and fix it. Okay, and of course I said ignore the order because if you're dealing with sets, you have no idea what's going to appear. Okay, 17, 18, okay, 2 more, 1 more, okay, 45, I'll click, okay, there we go. Wrong type of brackets, yeah, okay. All right, so there's a bit of a surprise in there because I kept doing intersection, but it doesn't really matter. You're just repeating the thing over and over and over again, and of course, you're returning. Oh, now we have to look at this. Okay. Although res started off as being a list, when you calculate an intersection of a set in another set, you get back a set. Okay, so eventually you return the set. Yeah, so there you go. That's kind of a surprise. That's why that one was a set of 40 and not a list. Okay, what type of data structure? Oh, wait, this has an episode. Would this make any sense? Yeah, okay, no, that's reasonable. Sorry, I thought it had something to do with my data structures course. And there is some reason about which one I picked and why. Okay, so there's no really 100% correct answer, but I'll talk about what I've got. Okay, so most people went after a list. A bunch of people also picked a set. Okay, the reason why I didn't pick a set for this one is because a set means, which pancake is being stolen? The very first one. So in a set, can you get a hold of the first item in the set? And the answer is no, you can't, because there is no concept of an order. That's why I thought, okay, no, it really is not really a set. A list works perfectly fine because you can access the first item. And I decided that it wouldn't be a tuple because you can't modify a tuple.
Yeah.
Okay, so that's why I picked this one.
Hyper.
Hypertuple is something I made up just because I needed 4 answers. Oh, yeah, that was easy. We're doing 16. Okay, I think we'll probably finish them all. Okay, a couple more. I think maybe one more. The answer. Otherwise, I will stop in 10 seconds. Okay, so maybe the person's disconnected. Okay, here we go. Well, I guess did an awful lot of work to try and work that out. Okay, and in the end, it was just true. Huh? No, okay, let's go through and look at this very carefully. Take a look at the return. You're asking the question, is temp equal to something? Okay, that is one of 2 possible values. True or false? And since false isn't there, I don't even need to do all the other work. So that's why I'm saying if you worked through this, you were going through, okay, add, and then add all these other items, turn it into it, and then doing a union. Yeah. Okay, well, it was really just this. Okay, so yes, that falls into the category of trick questions. No, actually it isn't, because sometimes functions just return true or false. So do look for that. Ooh, that's a big program. But it's a small program. Why is this written so big? Oh, there's one more question afterwards. Okay, I think we will have just barely enough time. Okay, but I'll stop this. Why did I give so much time for that? Okay, I have to go through and fix all of these. I'll stop this at 60. Or if you answer all the questions, I will. Okay, so I'm going to stop at this point. Ah, good. Okay, so most people got it, but there was still some surprising answers. Yeah, remember tuples, there is no append, you can't modify it. You might be able to concatenate with a plus, but you can't append. All right, so that's what that one is. Okay, so one more. Hopefully it's not like what could you put in a blue box to make the program run without runtime errors? Ooh. Okay, again, at 60, I'll stop because I see we're out of time. Okay. All right. Well, good. I mean, no, it's an equal thing with lists. No, you can't do that because the add operation is just for sets. Okay. Append for lists. I mean, there are some things for dictionaries, but there wasn't anything about dictionary. Okay, there was something about creating a dictionary, but yeah, .add is for sets. So really, I should have pushed this off for 1 week later or one class later. Yeah.
It's written sorted. Sets can be sorted.
Well, I guess. Hey. Let's find out. Okay. Next. Okay. Let that thing finish. Well, we come back to here. We better find out if a set can be sorted because that certainly sounds a little strange. Okay, so here we go. Data. Okay, there we go. There is a set. So let's print data. All right, that works without a problem. And what happens if you say v is equal to sorted data and print v? Yeah, by calling it sorted, because sorted normally works with lists, it will automatically turn something into a list and then sort it. And then return it as a list. So that was the trick on that one. Or sorry, another trick on that one. Okay, there you go. There's the winner. Okay, thanks, and I'll see you next class. Sorry for being a few minutes late.